Hello everybody, welcome to episode 3 of my networking show. Today's topic, routers. So Adam, can you tell me how a router decides how to forward a packet from the source to the destination? Go. So we have computer network A trying to communicate with computer network B, right? In order for that communication to happen, we need a router. And as you know, routers work on the layer 3 of the OSI model. That means IP addresses, logical addresses, that means, packets, routing protocols. And when you take a router out of the box, none of that is configured on it. So when you take a switch out of the box, it works. You can connect computers to it, they can communicate and all that. But a router, if you take it out of the box, it doesn't do anything. You got to configure it. So speaking of how the two computers communicate across the networks, let's assume the routers are already configured. So on the router, maybe it's running iOS 15.8 is the latest, but a lot of companies still use 12.5 even, like the 12 versions of iOS. And then, so there's a routing table in the running configuration, and the routing table is the rule book that the router plays by. And when you can type in these show commands like show IP route, show CDP neighbor, show interfaces, and that it shows you a lot of information and stuff like that. So the routing table has these big lists of all the network IDs, all the networks, and all the other routers that it's directly connected to. So, and it picks between three factors to determine how to route the packets. So the first factor is prefix. When there's an IP address, there's a CIDR notation at the end. That means there's like a /30 based on the subnet mask, based on how the network engineer subnetted, uses VLSM to design the network. So whatever has the highest subnet, like a /30, would be preferred over a /28 according to the router's default configuration. But let's say the prefixes are the same. Let's say there's two networks that are or let's say there's two routes to the same network and they're both through a /24 network. Now it goes to the administrative distance. That's how it decides. So, OSPF has 90 administrative distance, EIGRP is 110, so it would pick the OSPF over EIGRP. And the next factor is metric. So let's say we have 3 different interfaces all connected with a static route. So they all have the AD of 1. And all the metrics are 0. But when you configure it, you can add a weight to it, it's called. So you can make sure that the metric of one static route is 5 and the other one is 0. So it would pick the lower one that's 0. And then, the route's always going to use that route to send the packets out. Now, as you know, we're not going to be working in companies with only one router. So maybe a static configuration could be used on one router or maybe 5 routers. But most companies, 50, 80, 100 routers and hundreds of networks and VLANs and stuff like that everywhere. So configuring a static route for all the networks, that would take years. It would be a nightmare. So now we have these things called dynamic routing protocols. We got Hsrp version 2 that uses hops to determine routes. By the way, we don't use that ever. And then we have EIGRP. That's a Cisco proprietary protocol, and it only really works well with Cisco switches. So a lot of companies don't use that either because they like to keep their options open with different brands, different vendors and stuff like that. So the biggest players in the market right now are OSPF and EIGRP. So now when you're looking at a routing table and when you're configuring it, the OSPF has a lot of things involved too when it comes to determining which route to use to get to the right packet. A lot of routers together, maybe computer network A and computer network B, like we were talking about, has multiple routers in between it. So it doesn't just go through one router, it goes through maybe 5 routers. So all those 5 routers need to have a relationship together. So that means in OSPF, we got these point-to-point connections. That means you can have a Cisco 2900 router. It's a modular router. You can add these WIC cards in it, which is an interface that you can add to the router to connect a point-to-point serial connection. And these serial connections, they don't really need a MAC address either, which is cool because, when the computers are communicating, the source and the destination MAC address changes. but the IP address doesn't change. But through the point-to-point connections, you don't need a MAC address for that, so it adds some speed to the process of it. And then the routers are using a switching function. They're not a switch, but they're taking the packets from one interface and switching it over to the other interface to go through the point-to-point connections. And this is all determined by, in an OSPF environment, we got areas, and then we have a designated router that sends all the information to all the other routers. And all the routers have the same hello timers, the dead timers. They all have to have the same subnet on their interfaces in order to form neighbor relationships. And this all could sound pretty complicated. So I'm actually going to go ahead and make another video with a lab so that you can visualize everything that I'm saying, because this is a lot to talk about, obviously. But just one more thing that I want to talk about with how routers decide. The last one's called Hsrp. So Hsrp is cool because it's imagine there's two routers, and now the computer that's talking thinks that there's only one router. So that's what Hsrp is. And the benefit of that is it's virtually showing one gateway, even though there's two gateways. If one router fails, it will automatically go to the other one. So, that's pretty cool. But anyways, I hope I've been able to explain properly how a router decides how to forward packets between networks. And you know what? That's all I can say today. I'm gonna make a follow-up video, like I said, showing a diagram, going over it with images so that you can visualize more what I'm saying. And that will be a lot of fun. So look forward to that, and I'll talk to you guys on the next video.